am Professor Zida from National Taiwan Normal University. I'm honored to be the chair of the jurors for the Physics 5. And I think this afternoon you will give the best performance for your presentation and also for your discussion. Okay, in the beginning, I'd like to have jurors to introduce themselves. Okay, please.
Hi everyone, I'm Lee from Gongchang University.
Good afternoon everyone, my name is Junliang Lee from National Yangming Jiaotong University.
Okay, please.
Hi everyone, I'm Jun from National Taiwan Normal University.
Hi everyone, my name is Xin Chen. I'm also from National Taiwan Normal University.
Okay, now I'd like to have 3 teams to introduce your teammates and the name of your team. And we start from reporter.
Hello everyone, we are from Team Eco R1, and my name is Wu Xiaoxi, and she is Lai Chenxi, Lai Huiwu, Bo Zilin, and Zhang Yujun. Thank you.
Thank you. The opponent, please.
Okay, so we are from Linko Control, and this is first time that we are in TYPT. And my name is Eugene, and this is Captain Gary, and this is Amber.
Okay, thank you. Reviewer, please.
I'm Ethan from Indo High School, and our team is MP Fresh. And my name is Ethan, Alan, Michael, Justin, and YC. Thank you.
Okay, thank you. Now we should start the stage 1. I'd like to have a reporter to challenge. I'd like to have an opponent to challenge the reporter about the discussion problems. Oh, you only have number 14, right? Okay. Sorry, my bad. My mistake. Okay. You have 5 minutes to prepare for your presentation. Okay. Okay. Another thing you need to do is to write down the presenter's name on the board, please. If you're ready, please proceed.
Okay. Hello everyone, my name is Sharon from Team Echo R1, and today I'm going to report problem number 14, ruler trick. And here's the problem statement. Place a ruler on the edge of a table and throw a ball at its free end. The ruler will fall. However, if you cover a part of the ruler with a piece of paper and repeat the throw, then the ruler will remain on the table while the table will bounce off it. Explain this phenomenon and investigate the relevant parameters. And here's our observation video. So as you can see that we release the ball, and on the table here is a ruler and which is covered by a paper, and when we release the ball hits the ruler won't fall. So we will mainly focus on how do the forces act on the ruler and how do parameters affect the balance of the ruler. And here is some simple observation of it. So for the first video, as you can see that there is no paper cover on the ruler, and when we release the ball, the ruler will fall. However, when we cover with the paper, and as the video I just showed in my problem statement, as you can see that the ruler won't fall. And if we raise the ruler by put something under the ruler, and as you can see that when the ball hit it, although it still has a paper cover on it, the ruler falls. And also, when we cut some holes on the paper and release the ball, the ruler also falls. So we can guess that it's the air pressure which flow into the air cavity cause this phenomenon. And here to make sure that it is affected by the air pressure, then we do this observation. So here is the first observation that we cut a paper which is 30 centimeter times 25 centimeter. And as you can see that the ruler won't fall. However, if we base on its proportion and cut the ruler's length, not ruler's length, cut the paper's length, the ruler will fall. And we think that because we change the area of the paper, it may change its weight. And to make sure that it's not affected by the weight, then we stick the paper that we cut down and stick on the paper so that it will be the same weight. And to do this experiment, so that as you can see that the ruler still falls. So we can make sure that it's not the weight of the paper push the ruler stick on the table, and it's about the air pressure effect on it. So in our parameter, we're trying to find out the relationship between the air pressure in the air cavity and the fall down phenomenon. So here is our theory about the torque. So here is that when we put a ruler on it and cover a paper on it. And here is some definition of this theory. So the L here is the length of the whole ruler, and the D here is the distance between the edge of the table and the end of the ruler here. And the K here is the distance between ball impact point here and the end of the ruler. So we'll divide a ruler into two parts. So the first part, which is part A here, is that the ruler will touch the table like this. So for this part, we all know that the torque is equals to the effort arm times the force. And the effort arm here is the whole length of the ruler minus the D here. And the force is these two times. And for the part B, and here, as you can see that there is a green arrow here, and which is the atmospheric pressure on it. However, because the ball still not hit the ruler yet, so we can, in this situation, we still don't need to consider about the air pressure, about the atmospheric pressure. And here is about the part B, which is that it doesn't touch the table, and it's also a part of the ruler. So we also use this formula to calculate it. And here, I think we can notice that here we also need to consider about the force that the ball gives to the ruler. Okay. And here is, I'm going to talk about how will the air show when the ball hits on the ruler. So when the ball hits to the ruler will like have a slope, and it will create an air cavity here. And when at this moment, then here we'll have some air flow into this air cavity. However, because the air channel is really small and the air can barely flow into this cavity, so that the air pressure, which is PT here, will be really small, and it will be smaller than the atmospheric pressure. So as we know this formula here, then we can get the total torque of the air pressure which affects on the whole paper. And the delta A here is the area of the air cavity, and this part is that the whole area of the paper minus the area of cavity. So here, as we got the 3 torque of it, and we can use it to get the solution of D. And when we got this formula, we want to know that if we change our parameter, like the delta A here, delta B here, and the K here, how will it affect to our D? Because we know that the D will affect the torque of it. So when the D be bigger, then it means that it will be easier to fall. Okay, so here's our setup of our experiment. As you can see that we use a removable stand and put a release tool on it to release the ball. And we put a ruler and a paper on it. And we will make sure that every time the ruler and the paper, they're at the same position. So for our first parameter, we change the weight of the ball to 20, 22, and 24 grams. Okay, so for this chart, I want to give a definition of it first. Here, as you can see that here is a gray line here, and for this point is the critical condition of it, which means that if the release height is smaller than the critical condition, which means the ruler won't fall. And when it is bigger than the critical condition, it means that the ruler will fall. So for one chart, I will divide it into 2 parts of it to discuss. So for the same release height like this, when it is at the same release height, well, according to the solution of D, we can see that when the weight of ball increase, which means the impulse of it and the area of cavity of it will all increase, and which means that it will decrease the D. And as you can see here, also when the weight of ball increase, like the gray here, the D will also be decreased. So it is fit to our theory. And for the trend, when the weight of ball increase, like this. Like the gray here, because this is 24, which means that the torque of part B will increase. Then the limit releasing height will be decreased, which means that it will be easier to fall. And next is the second parameter that we change the ball impact position, which is the K here. It's the distance between the hitting point and the edge of the ruler. And we change it into this 3 centimeter. So here we got this chart and also divide into 2 parts to discuss. So when it is at the same release height, as you can see, because of the solution of D here, then, sorry, I didn't mark it. When the K is increased, then the D will be increased too. So here like this, when the K is increased like the gray here, then also the D here will be increased. And for the trend, like this, when K is increased, like the gray here, the torque of part B will be decreased, and which means that the limited release height will be decreased from here to here, and it means that it will be hard to fall. And next is that we change the elevation under the paper. And we change it that the 0 is that there is no elevation under the ruler, and for the 0.18 centimeter under the ruler. Okay, and here, for when it is at the same release height, we can know that when the area of the air cavity increase, the D of it will be decreased. And for the trend, and for the trend, when the elevation increase like here, the channel for air to flow into will increase. Then, which means that the limiting release height will be decreased, and it means that it will be easier to fall because we all know that when the channel for air to flow in, which means that the air pressure in the cavity will be increased. Then it will cause it more easier to fall down. And next, we change the distance between the air circulation and the ruler. So when it is at the same release height, I think we can skip this part. And for the trend, when the distance between air circulation and ruler increase, which means that the channel for air to flow into the air cavity will increase, and the limiting release height will be decreased. And because we can give an image that when it is the distance decrease, the air flow into will be directly, and which means that the air into it will be increased. Okay, next is about the size of paper. When the size of paper increase, which means the distance between ruler and the edge of paper will increase, so that the channel for air to flow into will be decreased. Then it will be harder to fall down. So here's our conclusion. When the torque of part B increases and by these 2 parameters, which means that the limiting release height will be decreased. And by these 3 parameters, we talk about the air channel for it, and it'll be like this. And that's all for my report. Thank you.
Thank you. How about opponent? Please.
So can you explain why does the experiment demonstrate? The experiment in the beginning demonstrate that the main cause of the phenomenon is the atmospheric pressure. You mean that why atmospheric pressure acts on the phenomenon, or what? How does the experiment demonstrate? So I think you want to know that how will the influence affect by the atmospheric pressure. Do you mean this? I think how does your experiment show that the main factor of this phenomenon is atmospheric pressure? Okay, so as we know that when there is the air cavity, the the air pressure of the air cavity is different with the atmospheric pressure. So this pressure difference will cause it a force to that the atmospheric pressure to like stick the paper onto the table and also stick to the ruler. So it will just like recover to the table but not fall down.
So I mean like atmosphere pressure holds the paper and so the ruler will not fall down.
Yeah, you will give it a force.
And can you explain like the picture 3 in the
In,
like
in the
very beginning?
in the beginning. Which? For the observation or for the theory? Sorry.
Okay, time's up. Sorry, it's time for preparation, please. Okay. Opponent, please take the floor.
So I'm an opponent in this round. So the problem statement is stated here. Yes. And for the total performance, we think that they have clear experimental setup and they are well organized. The ideas are well organized and they combine the theoretical calculations and physical experiments precisely. And for the weakness, some controlling variables are not excluded. So, and we have some other ideas about the variables, so let's begin our discussion.
Okay, please, proceed.
So I think we have changed the mass of the ball and other variables such as the position. Did you change the position of the ball?
Position of the ball. You mean the hitting point?
Yeah.
No. I have the parameter that we change the k, which is the distance between the hitting point and the edge of the ruler. I only changed k, the hitting position in that parameter, but in other parameter I didn't change the hitting point.
So did you consider it as a control variable?
Yeah, it needs to be considered because it will change the torque of the part B.
So how about the, I want to add a point that if you would change consider the material of the paper as one variable,
The material of the
in
paper.
the calculation part, you have mentioned that it's has a like triangle shape under
The air cavity.
yeah. So if the paper is like more harder, it's more harder to bend and it will.
It means that if it is harder to bend, the air cavity will be decreased or
The shape of the paper will not be like that, and it will be like flat and the.
yeah, I think it also can be a parameter of it. However, because the data I calculate is that it is success or not, which means it is full or not, right? So I think the main we need to consider is that the torque of it, will it change to that it falls down, which means that the torque of part B will be greater than part A and it will fall down or not. And if you say that the air cavity of it, I don't think it is it is fit to the main thing that we need to find.
So, also, what do you think of the friction between the table and the ruler affect the experiment?
Yeah, I think it will also affect the experiment because like when the friction between these two increase, it means that it will be harder that the ruler to given the force to that the gravity increase, right? Agree with that? Yes. Okay. And however, as what I just mentioned is that we just see the success or not. So yeah, I think you mentioned the friction and also the material of paper is. Well, I think it's the same thing, but it's not fit to or what we mainly focus on because the problem statement wants us to find if it is full or not, right? And well, in your you say that I weak. My cons is that I didn't explain my parameter well or wrong. Control variable. And what do you mean? I think I can explain it more detailed for you.
Can you go to the experiment?
Okay. For the setup or the parameter part, like this.
I think there are like more controlling variables that you can mention.
Okay. So like this.
Just for example, like because it's
okay, well, I think I can mention it. So for first, the size of paper we will we will control it is the 25 centimeter times 20 centimeter. And also the direction of it is the horizontal and not the straight. And for the L here, the whole length of the ruler is 31.3 centimeter. And the K here, which is the distance between the hitting point and the edge of the ruler, is 1.65 centimeter.
So for
11?
because the releasing tool and the ruler contain a certain amount of height, so how can you like control if the ball falls on the same position on the ruler?
Oh, okay. Before we put a ball at this position, we have put a pendulum on it. I don't know what's that. Okay, I can draw it for you. So, the pendulum is it is the release tool like this. And before we put a ball on it, well, like here is a rope, and here is something is really heavy, and so as it's because of the gravity, so it will like and here's the ruler. So I use this pendulum system to make sure that when the ball fall down, because it will fall down in straight, right? So it will fall down at this position.
Because the question tells us to consider different parameters. Like, do you think of other parameters that can be done in this experiment?
Okay, well, actually because of the limit of time, I didn't show other parameter, but we also changed the shape of the size of the paper, which means that, okay, in my observation, I also show of it. It's like this, the shape, the size of it. So when it becomes small, and I think it also, it also needs to, it also will be relevant to the airflow channel. Like when it is become small and when the ball hit here, it means it will create an air cavity in a really short time. So when the size of the paper becomes smaller, which means that the channel of it will be more direct, and because the ruler will be more easier to fold because the air pressure also increase in the air cavity.
So for this one, does the ruler, like, is it outside of the paper, or is it all folded like in the
ruler or what do you mean? Like
is the if it's a ruler, is the paper like this, or is it like
to picture to show why you want me to come here.
this? We ruler take on the top, and if it's in the ruler like this, so this is like.
Oh, it's the first one. This one? Yeah.
So both of them are the first one.
Yeah, both of them. All experiments in my report are like the first one. Because if it is the second one, as you can see that the ruler is over the paper, right?
Yeah.
And I think it will also have another like to create a bigger channel to let the ruler to let the air flow in. And I think if it is at the condition 2, all of the experiment involve the ruler will fall.
So how does the energy transfer conservation affect the
energy? Sorry? Can you say that again?
So what do you think about the energy transfer and conservation affect the experiment? Because the energy might change to the sound or the heat due to the fusion.
Okay, good. Oh, you mean that when the ball hit on the ruler, And in this process, it will have some energy like transfer into the heat or other energy.
Yeah.
Well, sorry, but I don't think that is the main point to discuss in it. But I cannot. Oh, yeah, I think I agree that there will be a little like energy transfer into like heat or what, but that's not the main point of this number, right? Well, I think maybe we can like discuss about this part of it, because I think that the pressure difference is really important in this one. So maybe we can discuss this.
Can you like explain like how this will how long will because when the ruler is pressed by the ball, it will become like that figure.
Yeah.
And so how long will it take to like return?
Oh, you mean that because in this process it will create a cavity, but in the end the cavity will just gone, right? And you want to ask me how long will the cavity exist? Okay, so but actually we didn't calculate the time that the cavity will have, but I think the time is really short, because like what I just mentioned, the air go into it is really hard, and it's also because that the time that the cavity the cavity exists is really short. Okay, and for this I can show you like the video of it and to prove it. So, and please play the video. Oh, not this, the other one. As you can see, here, it's really a short time.
So do you think like the length of the paper will also
The length
because
of
you
the paper?
change the area of
The size of
the
paper. Yeah, the length of paper. Well, for this, you are changing. Okay, and I think I change in the end of my report. Okay, and okay, and here is some other of my report that I didn't show is that we also observe when the direction of paper is at different, how will it affect the air cavity. So like when the paper is put
Okay,
at the horizontal.
the time's up.
Okay,
Okay, please. Please summarize. Please summarize the discussion.
So we asked several questions about the parameters of the experiment, and the reporter mentions that answered all of my questions with fully understanding the physical phenomena. And however, we think that those other factors such as the position of the ball and the material of the paper might also be a consideration in this experiment. So I think overall, the reporter understands the phenomenon really well.
Okay? Okay, I'd like to have a review, please.
Okay, so I would like to ask the reporter first. So I'm wondering where is the force of the pressure difference? Where exactly is the area that it applies on? Because as you stated, can you as you stated, like the graphic journal is like shows that the force is applies on the whole area of the paper, like the roller and the paper do connected. So are you meaning that the whole application Where you
Oh,
guys?
you mean the air packet or what?
I mean, just the force. Okay, okay, I will skip it. And I'm wondering, do you consider the elasticity of the ruler, like the flexibility?
You mean it will bending?
Yeah, would it bend?
Yeah,
You-
yeah.
But so you didn't put
No,
it.
no, I didn't. Yeah, I
But-
think I can say it in the remote.
Okay, and so okay, that's it. And for the opponents, like as you point out some other variables like the ruler, so how do you like that one? So you're saying like the inserted length of the ruler will affect the whole phenomenon. Is that right?
Yes.
Yeah. So what do you think? Like as you stated there, if the ruler goes out of the paper at the end of it, what do you think it will happen?
I think the ruler will go.
Okay, I see. So what about the water? What do you think? What would the votes?
Yeah, I've answered the opponent that I think if it is at a condition 2, it will fall down.
So can we just go? Can we go?
For my report.
Yeah.
And which page?
Page 9.
Page 9.
Yeah. There's a little. So as you. So as you stated here, the graphic control is fully combined with the ruler is fully attached with the paper, etc.
Yeah.
So this appears that the force of the caused by the pressure difference is applies on that whole area. Is that right? Am I?
Yeah.
Oh, okay.
Yeah.
So what do you think of the force applies on there? The force of pressure difference.
So I think the force of pressure difference is like 9
Okay, thank you.
Thanks.
Time for preparation.
So, greetings to honorable judges and fellow contestants. This is the reviewer from Team Intel Fresh, and let's move on. So, I'll start with the problem statement. So, they're main focus on the forces acting on the ruler and the relevant parameters. And for the reporter, I think they got a really clear explanation of the phenomenon because they investigate how the pressure difference and air pressure applies on the ruler and the paper. And I think they do put some crucial details they took into consideration like the collision point of the lens. And but we do think that because they only do very few variables, so we suggest that there should be more variable consent because yeah. And so in their theory, I think they just put it. They were like going way fast, and I think the opponent did not like quite catch. And so and about I just realized the diagram they drew it are like differ in their demonstration video. And for the opponents, I think the thing they did really great is about they raised up more variables because it should be like more variables will be concerned, and they discuss about how the experiments are conducted. But our suggestion is that the question should be more follow-up because it's a bit without connection between the questions. And move on. So the first in the discussion, the opponent asked, do you consider about the hidden points? And so the reporter stated that they do consider, like they define the K for the collision point to the edge of the ruler. And our opinion is that we really we think that the reporter have done it well because the length of the collision point do affect the torque, the formation of torque. And the opponent stated that what is the friction affects the results. And the reporter says the larger the friction is, it will be harder for the ruler to flip. But I think in our point of view, well, we think that friction, the discussion of friction should be on like the holding, like could the paper hold the ruler, like the contact moments of the ruler and paper. And let's move on. So the opponent raised another one about the energy transfer, and reporters stated that there will be slightly energy transfer, but it won't be the main focus of the experiment. And our point of view is like, although the energy transfer might affect how the theory applies, but as they said, it will agree then it wouldn't be the main focus that we're concerned. And about the missing points, I think about like the diagram, because as I stated, the diagram they drew is like different with their demonstration video, and like inserting lens and the formation of the ruler. I think it's all about the variable. Like we should add up more variable about the ruler, about the just more variables should be conjectured. And I think they missed the one is really like the position where exactly the force of pressure difference is exerted on. I think that would totally affect the torque, the calculation of the torque. And that's my review. Thanks.
Okay, thank you. Concluding remark from reporter.
Thanks to the opponent and reviewer, here's something I want to explain more detail. So for the reviewer, you have mentioned that it will have some deformation or bending for the ruler. And I also think that it will happen. So in our experiment, we also found the modulus of the elasticity of the ruler is the 0.36. However, because it also needs to use in the formula, but when we got the solution of D, it is unclear to see the relationship between the D and our parameters, so I didn't put it in my report. And okay, and I think I still have time. So okay, back to the problem statement. I think that in this question, the problem statement requires us to find why the ruler will fall. And I think the main reason is that the difference between the atmospheric pressure and the pressure in the air cavity. So, and the parameter we did is all want to find how well the air difference that cause it will success or not. So like this part, we will change this, and it will let the air flow into it. The volume of air flow into it will change. So it will cause that the ruler will fall or not. Okay, and I just finish my answer to the opponent is that when we change the direction of it, and also it's because that the length at this part it will be changed. So it will also change that the channel that the airflow into it is direct or not direct. Okay, thank you. That's all for my report.
Okay, thank you. And I'd like to invite some questions from our heroes. Okay. President Chen.
So regarding information of the ruler, so my question is, so suppose we have different kind of material but with the same thing. So then we have a plastic and rubber and also metal. So they have different bending rigidity. So I would like to ask your comments on the effect of the rigidity of the ruler on your equation result and the reason why. So let's start with the opponent, and then the reporter, and finally the reviewer. Okay?
Can you state your problem again?
Okay, my problem is that if you change the bending rigidity of the ruler, like you have some one like the rubber, and then the middle one the press, and the steel ruler will be the most difficult to bend, correct? And then that will change your result. And then so I want you to predict its effect based on different bending rigidity and your reason.
Can I answer?
Because that's your question, so that's why I'm putting you
Okay.
able to start.
So I think whether the rulers, what the ruler is made of will affect the time length the ball is bounced up.
And then the reporter.
I guess based on my theory, so according to the first analysis here is a first up to the because it wants to like recover, and I think if like the material changed to like iron, and because the amount of elasticity of iron I think is more than the plastic. So when it is be more, and for the torque of the part B, it will be decreased. So that I think if the material, the elasticity of the material is more, and I think it will be easier to fall.
So as I stated, I think in my point of view, I think if you change the rigidity or elasticity of the ruler will bend differently, right? The deformation will be deeper. And I think which contributes to a spring force like will be a drag force to the force coming from the ball. And also it might affect the time, the collision time of the ball. It might stay on the ruler when the material is different.
Okay, any more? Okay, please.
I wonder if your equation for the reporter, little d,
Yeah.
can be reduced to some simpler situations. For example, there's no paper to cover.
There's no paper.
Can your equation be reduced to that kind of situation?
Do you mean that when the
Well, the paper is not there in there.
When
When
there
there
is
is no
no-
paper at all.
no paper cover on it, and for the D part?
For your little d equation, the little d,
Yeah,
Will not change.
will it change or not? Well, I think no, for the torque that we calculate for part B, it will not be changed, but it will change the part A. And it will just cause the difference between these two parts or, oh no. Okay, I just.
That's all right, yeah, thank you.
Any more questions? Okay, please be seated. We will give them the grade. Okay, the score for the reporter, please. 7, 5, 8, 7, and 8. And the score for the opponent, please. 4, 4, 3, 4, and 7. And the score for the reviewer. 7, 5, 5, 7, and 8. Okay.